This is my motion analysis presentation. We'll be analyzing the movement of a 2-ton tinfoil ball as it hits a cartoon character. Thankfully, he gives us some information in the episode. We know it's traveling at 200 miles an hour and that it weighs 2 tons. So we're going to make some assumptions. We're going to assume it's traveling in a straight line, that gravity isn't really having an effect, especially since he has directly at us in the video. We're also going to assume that the episode's occurring in real time so we can keep track of the time. You can look at these other assumptions later. So here we have the velocities turned into feet per second, so they're easy to use, and the weight converted to pound mass. We're going to utilize our kinematic equation for velocity given time, and the sum of forces equals the mass times acceleration equation. And so let's see the video to see how much time passes.
Helplessly as the unimaginable electromagnetic forces pull the eastern seaboard, thereby advancing route.
So in that moment, it's at 0 velocity. It's about 9 minutes, 11 seconds.
Shut up. Well, that didn't work. Now we have a 2-ton ball of tinfoil traveling 200 miles an hour direct.
There we go. It takes about 12 seconds for it to be at 200 miles per hour. So going back to the presentation, we're going to plug in that change in time of 12 seconds into the kinematic equation to get our acceleration of 24.4 feet per second squared. We're going to multiply that by the pound mass to get the pound force that's exerting, which is about 3,036. So what does that feel like? In a cartoon world, assuming that the average anvil weighs about 500 pounds, that is 6 times the amount of anvils that would be falling on Wile E. Coyote.